Good morning, everyone, and welcome to our .NET Language and Runtime Community Stand-Up. Today we have a special guest, Jan Kotas, our Runtime Architect. So let's do a quick introduction. So my name is Imo Landworth. I'm a PM on the .NET Platform team. And then I think
I'm Kathleen Dollard. I'm a PM on the. Hi, I'm Kathleen Dollard. I'm a PM on the .NET team doing languages in the SDK.
Rich.
Oh, I thought Jan was next.
I think you swapped it earlier.
You're next.
Okay, so yeah, I'm Rich Lander. I'm a program manager on the .NET team as well.
Hi, I'm Jan Kotas. I'm the .NET Runtime Architect. I kind of actually don't really like the architect title. I usually just say I work on .NET Runtime. And I have been, associated with .NET in one way or the other most of the time since 2001. So a lot of history.
We are so happy to have Jan visiting with us today to answer all of your questions about the runtime and to dive deep in some of the things that we're doing around security, performance, new platforms, tons of stuff going on with the runtime. And we're going to get to have a deep dive into that today. So we are super looking forward to you, helping us out here with your questions, all the folks online.
Okay, so should we just start with some? Well, actually, yeah, that's right. We were going to talk about RC2 first.
We're gonna admit to people we let it out the door. It's ready to go, and we've got a blog post that covers the high points and references other places you can go for more information.
Yeah, so I'll just quickly speak to this since I wrote it. RC1 and RC2 are our two go live releases, which means that you're supported running them in production, which is super cool. We've been talking to both companies and as well as Microsoft teams about doing exactly that, running their code in production. And so we've gotten some early feedback, and we've been working with those folks, which is great. Normally with the previews, I talk about the features that we just shipped. With the RCs, that kind of doesn't make sense anymore because almost all the features are right, and we're just working on quality. So for the RC1 post, I focused on foundational features, many of which won't see their full fruition until .NET 7. And then for this one, I talked about kind of more the UX most obvious features that will affect your day-to-day coding life, and that's why I focused on C#10 and the templates. So it's there to download and use, and we hope that you do just that and give us tell us how it goes. Anything more to say about that?
I don't know. We don't have any questions yet, so why don't we just dive straight into the runtime, and we might start with things that the runtime's doing in .NET 6, just an overview of that. But since Jan's here, let's take advantage of that and deep dive into it.
Yeah.
Do you want to start with some questions, Rich?
Well, how about we just start with a quick overview of what the runtime does and what are its most obvious components.
I think that sounds great.
The runtime, the first there's an interesting question where the runtime ends. We have the .NET Runtime repo. So one would say, okay, in .NET Runtime repo is what the runtime is. And that's, one kind of definition of the runtime. Basically, everything that what's in .NET Runtime repo is the runtime. On the theme, we actually, when we talk about the runtime, we often don't mean the whole .NET Runtime repo, but we actually mean just the kind of the lowest level of the runtime. The key components of the low-level runtime are garbage collector, the JIT, the just-in-time compiler, then there are like several kind of, subsystems like interop is big subsystem. Diagnostics, support for debuggers and profilers is another big subsystem. And the component that kind of holds it all together, that's kind of in the center, that everything connects to, is type loader, or we often just call it a loader. We actually, years ago, somebody ingested the runtime sources into one of those tools that tries to analyze the architecture and tries to draw the dependencies, and it actually looked exactly like that. The loader was the bubble in the center, and on the side there was garbage collector, there was JIT, there was the class libraries at the top, and so on.
So, Jan, when you talk about interop in this context, is that interop with native, or is what are we interrupting with?
Yeah, the interop in the runtime context, it means interop between managed and unmanaged code. So it's kind of DLL import and com interop, binati interop, all these kind of interrupts.
Right.
Again, the interop is kind of overloaded term, because in broader sense, interop can mean sending RPC requests from one microservice to another microservice. It's not what we usually mean by interop,
right.
And we are on the runtime team. So many of these words are kind of context specific.
Right. That's why I wanted to clarify that down, because in my language as part of my life, then that means something different than it does here. So here we're talking about deep level systems talking to each other, which of course is key to so many things that actually happen with the runtime. So what's coming in .NET 6? Is there anything new people want to know about, other than we're always trying to go faster? But is there anything to call out for .NET 6 before we start talking about big picture and what we're trying to do overall?
The working on the performance is a large part of what the runtime team does. There are big, both big and small performance improvements, in garbage collector, in the JIT, and throughout the system. Highlights that for the runtime, for the core runtime in .NET 6, I think probably the number one highlight is that we finally integrated the mono into .NET runtime, properly, so that we have we have one runtime. Kind of, it's still two different runtimes, but we have at least one repo where both things live, and we can kind of work on better sharing of the code, and so that I think is the probably the top highlight.
I'm sorry. I think once upon a time, people thought about the .NET and Mono as two choices. And there wasn't a lot of clarity as to why they both existed. And now I think we have more clarity on that. So could you speak to why we still have Mono and .NET sitting side by side, and what's the important aspects of each one of them?
Yeah. So we basically think about the different places where we need to run, and the mono runtime today is basically optimized. We think about it as a runtime that's optimized for the browser and devices, and Core CLR is the runtime optimized for server and desktop. It serves this kind of distinction serves us well so far. It might not kind of serve us well going forward, because there are, take for example, WASM WebAssembly on server, right? So it's server, so one would think, okay, we should just run Core CLR there. But on the other hand, we have all the support for WebAssembly in Mono. So what do we do about it? So when I think about kind of the long-term strategy for the runtime, I would like to see kind of the distinctions between Mono and Core CLR kind of blur, and be in a place where we have like configurable runtime, right? Where we basically say, okay, we would like to run WebAssembly on server for this type of workloads. So yeah, so let's see what kind of runtime would be best for it, and we basically pick and choose different components, kind of flavor of the garbage collector that works best for it, the flavor of the code generator that works best for it, and we basically like combine the components and build a runtime that's the perfect fit for that given scenario, right? We are years from delivering that vision, but that's kind of my North Star as the architect.
So we're getting
can we
some
go
good
to questions? Yeah. Exactly.
Eva, do you want to grab a couple of those?
Well, let's do the Project Loom one first.
Yeah, okay. I'd never heard of Project Loom before it came up there.
I disagree with what Emo responded with, so let's see.
Project Loom, yeah. So just to set the context for this, today when you write code in .NET, you often hit this problem with duality of async and the non-async words, right? You kind of, if you want to run, if you want to write scalable .NET code that runs well on servers, you cannot avoid async. Basically, the async operations are a way how to achieve scalability. The problem with async is that it's viral. So when you want to call an async function, your all callers of async functions have to be async as well for the whole system to work well. Well, that's all good so far, but the problem is, like, let's say you are building a big project, and you have some split between the sync and async, and suddenly you realize somewhere deep in the synchronous part you need to call an async function, right? That's pretty bad situation, because now you have to, if you want to keep following the best practices where async functions should be only called by another async functions, you have to refactor like big parts. You might end up needing to refactor big parts of the project to flip sync to async, and there are also performance consequences when you flip something from sync to async. So that's a problem, right? It's other languages, for example, Golang, they avoided this problem. They basically said, okay, everything is kind of going to be async, and we will do magic underneath, where it's you basically worry about it for people. And so in Go, you always write synchronous code, and the runtime will take care of the magic to make it scalable and kind of the asynchronous underneath. So now I can go to the Project Loom. So Java have historically been on the same plan as .NET, where all code is synchronous by default. And if you want to do the asynchronous things, you have to write the code in different way. But the difference between their approach with Project Loom and .NET is the Project Loom takes kind of the Golang approach to solve that problem. Basically, the Project Loom is saying, hey, we can just do the magic in the runtime, so you can write all async code. You don't need to worry about this sync async, coloring problem, and you can just write all sync code, and we will do the magic in the runtime to take care of the scalability issues that come with it. Now, what we are going to do about this in .NET, we had actually many hours of discussions about this. It's a very hard problem to solve. The challenge is that unlike Java, .NET is much lower level. .NET runtime gives you much lower level access to have, say, for example, great interop, right? Java doesn't have it. If you wanted to do interop, like calling ARM code from Java, you cannot just write DLL import and be done with it. You have to deal with like JNI and write a lot of it manually. So what that means is that ordinary Java code doesn't have things like pointers and pinning and all these things that kind of are good to have, are nice to have good interop story. But what the downside is that if you want to do something like Project Loom in .NET Runtime, it's between very hard and impossible, right? Basically, we can do Project Loom, but we cannot, if we just followed, stamped what Java has done, it would be very major change, very major breaking change for interop. Basically, none of the code that does DL import would work today, or it would work poorly. And, so we don't really know what we are going to do about it in .NET. We do realize that it's a problem. One potential solution is to just make async better. So there are multiple problems that come with async in C# today. One problem is the coloring. The other problem is performance. Right? When you convert a function from sync to async, it adds significant overhead. The overhead is something we think we can do something about. We can make it much better. It's still a ton of work, but that's kind of doable with enough effort. And we like projects that are a lot of work and deliver significant wins. So that's something we are considering. But kind of what we would need to do to make the sync and async distinction to completely go away, we don't know it.
So that's a good segue to this next question from Alex here. Can you address that one, Jan, since you're very much involved in a lot of these conversations? Like, it's basically saying, how does the innovation plan approach work? Yeah.
So there is a large difference between how we have done it in the past versus how we are doing it today. So in .NET Framework days, the C# team and the .NET Runtime team, we were actually in very different parts of the organization. So the C# were kind of the Visual Studio side of the house, and the .NET Runtime was different, many steps away from C# team. So if you like it or not, the organization structure always affects architecture of the software. So what that meant is that the C# features were often developed kind of without help of the runtime, right? So you can, for example, see it on the async, how the original async support in C# was developed. It didn't need any support from the runtime at all. Right? It was a standalone package and new compiler feature, and you can just run it on .NET Framework 2.0. And it allowed us to kind of move forward, but it wasn't. It didn't result into kind of great, well-tuned, system. At around the same time, we open source .NET and introduced .NET Core. We moved the both the C# team and the runtime team much closer together. Jared, who is the lead for the C# team, actually sits right next to me in the team room when we are in office. And that kind of results into the two teams working much closer together. So we had a number of joint efforts where we have done a C# feature together with runtime feature and make sure that the two work together. The example in .NET 6 is the support for the generic numerics APIs, that's actually the libraries feature, but the runtime feature is the support for the static generic static virtual interface methods, and here we had a number of examples. I think the first big feature we have done together was the span of T that required new work in the runtime, new work in the compiler, and we made sure that it works together. But since then, we have done many more.
Yeah, that's a great segue, and I will comment that it definitely benefits both, because there's features that the languages wanted to do that really needed to reach out to the runtime, and things that the runtime wanted to do that really needed to reach out to the language. And so it's a very happy friendship right now.
Yeah. Just to kind of put some more context on this. Typically, the runtime engineers are kind of more interested in the more low-level features. For example, the good example of that are function pointers. Function pointers, it's super low level. It's important for the runtime to have a great interop. But it's not that exciting from the language design point of view. It's so that the function pointers were primarily driven by the runtime, and C# team kind of were they had to do their share of the design as well. But it's that's how the dynamics work. On the other hand, when you compare it with something like pattern matching, it's really exciting area from the language point of view. From the runtime point of view, it's like, okay, we will just give you a couple of helpers so you can do it fast, but otherwise we kind of don't really have an opinion, right? So different features are kind of driven by different sides. That's the whole point.
Okay, we've got another question about what we call DIMs. So that was both runtime and language feature.
And static's coming up now in .NET 6 as well. Static interface.
Yeah. I think the biggest challenge with this feature was probably updating all the different implementations of the type system that exists to understand it. That's kind of the general challenge with updating the type system. So the type system, I said that the type loader that basically implements the type system is the central part of the runtime, but kind of the same logic is actually replicated in a number of other places, right? It's replicated in debugger, it's replicated in IO linker or IO trimmer. It's of course it's replicated in the language compilers. So I'm making sure that we update all the places where all the places that need to be updated to understand the new type system features. That's, I think, the biggest challenge. And sometimes we miss some. For example, for the statics on interfaces, we forgot that the C++ CLI is still a thing, and we forgot to validate that the C++ CLI compiler doesn't choke on it, and that actually forced us to change how we are. That forced us to change how the shape in which we are shipping that feature in .NET 6. We are shipping it as preview, but the shape of the preview changed.
So the abstract static methods and the whole work around static interfaces and all, that's to empower some specific scenarios under the hood, which is around the idea of constraints that are more generalized, particularly around numerics, which is super interesting to be able to have an ad that doesn't care whether you've got, what shape your integer is in. But are there other reasons? Are there other things that are happening with that are interesting, or any other work on that? Sorry if it was a badly stated question. I'm sorry.
I think this is the way I look at this feature. It's kind of a large collection of features. That's the reason why we are not shipping it as as a baked thing in .NET 6. We are shipping it as preview, so it will take us at least another year in .NET 7 to finalize it and make sure that everything works well together and it actually solves the problems that it was supposed to solve. I don't personally have much to say about the details, whether we kind of, I'm watching this set of features from a distance. I'm not involved in the detailed discussions. Looking back, there was a question about the default implementations for interface methods. That's something we have done, I think, for .NET 5, right? And it's nice that we got it done, but we have missed how we didn't thought through how we are actually going to be, whether it's actually going to be usable in BCL. So that's something, looking retrospectively, that's something we could have done a better job about, to think through how you would use it in BCL, maybe design it in a little bit different way so that it's actually usable in BCL with confidence. I know Imo, who is leading the API design reviews. I know every once in a while, there's a question, what about if we add this as default interface method? And the answer is pretty much always, no, we are not confident that it's going to work, right? So that's something to avoid this time around, learning from past mistakes.
Which ties into the question that's on the screen right now, which is that we consider VB and F# in the designs, but we do sometimes have something that is C# specific, because the work that's under there's a good reason for this. It's not just that it's not that we love C# more, even though it's a ton of people in C#. It's that so much of what underpins everything is written in C#, that when there's an improvement under the hood, even if we can't really expose it, and Span's a great example of that, that's going to benefit VB developers, even if they never actually use Span, because underneath the hood, it lets things run better. So the reason that you see things go into C# sometimes and then drift into the other languages as it's appropriate for those languages, or not, then that's because everybody benefits when C# allows something to improve what's underneath all of .NET. So as people from other languages look at that, it's good to remember that, yes, you benefit from this. There's aspects of string in particular that run faster because of default interface methods, even though you can't build those in Visual Basic.
Yeah, I will just add to that. For example, some of the low-level interrupt features that are going in C#, they are not necessarily exposed or usable from VB or F#, right? But the F# or VB are probably not the best languages to build, the large interop packages, the interop wrappers. So this is an example how, better support for interop benefits those other languages, even though it's not that, that low-level feature is not usable in them.
Yeah.
So that's a good segue to the question on the screen, which I know you care deeply about, Jan.
We do love, writing more and more code in C#. If nothing else, that's kind of the holy grail of the language and runtime design, to have the runtime and the compilers and everything implemented in the language itself. That's not how the .NET runtime started. Historically, the .NET runtime was, the core runtime was a large piece of C++ code, but over the years we tried to move more and more of it into C#. What helped with this a lot is some of the low-level interop features that we have built. Just a piece of history. I think I wrote first paper on that this is a good idea in like 2007. So it has been a long journey. So but if you look at the one thing I like to do is to just look at the binary sizes on disk. And what you can see is that the CoreCLR.dll, that's basically the unmanaged piece of the runtime, it's kind of not growing too much. Sometimes it shrinks a little bit from release to release. Sometimes it grows a little bit. The CLR JIT, that's basically the optimizing JIT. That one is growing because we are doing more optimizations, more complex optimizations. And also what's growing is the system private correlate. That's basically the managed side of the low-level runtime. And one part of it is that we are adding new managed APIs, but the other part of it is that we are moving more of the code from CoreCLR.dll to correlate that we are writing in C#.
So here's a type system one. Can you address this one?
The how to deal with generics or generic-like constructs. It's an interesting trade-off. The monomorphization, or I sometimes call it code stamping. It doesn't come for free, right? It basically results in code bloat. Basically, you have like very similar code stamped many times in the process. At the time we have done generics, it sounded like a good idea to set the balance between when we are going to do the code stamping versus where we are going to do the full specialization at the value type reference type boundary. And I know many people are kind of take it for granted, and they actually optimize their code to take advantage of it. I see this as maybe kind of optional configuration options. Maybe eventually, if we can show that it has actually benefit, I wouldn't expect it to be something that average developer is worried about. Basically have like runtime that comes with a good defaults, and it works well for 99.9% of the cases. It's only the cases where somebody wants to micro optimize something and the overhead of the code sharing shows up. That's
So to make this a bit more concrete for folks, I think what you're saying is, everyone knows about list of T, and so it has a contains method. And so I think you're saying that for different instantiations of list of T, that the contains method stays constant or is shared across them?
Yeah.
Is that what you're trying to say?
Yeah, as long as the T is reference type. So for example, list of object and list of string have the same piece of code that implements the contains. But say list of int and list of long, the code between those isn't shared. It has, the code is duplicated once it's JITed or AOT compiled. The advantage of the approach for int of or long is that the code is faster, but it's also bigger. The advantage of the strategy that we use for the reference types, is that the code is smaller, but it pays some overhead because of sometimes, for example, if your code does type of T, right, in the fully specialized code, the type of T, it's like we know exactly what the type is, so we just put its int. When the code is shared, type of T ends up being several indirections. Maybe there's some call to a JIT helper that basically has to compute the T based on your current context, right?
But that's a super small difference from most code, isn't it? I mean, so like for the code that almost everybody writes, they could never find that difference, could they, in their own performance? I mean, I think of that as just an incredibly small, just a small handful of extra instructions there. Is that true, or am I off base?
Yeah, I agree. For average code out there, basically, as I said, 99.9% people shouldn't worry about it. But we do have very enthusiastic part of the community who kind of like to super optimize things, and for those it makes a difference, and sometimes the difference is huge.
Yeah, for some of those scenarios, like some of the machine learning scenarios, they're already in a value type, so they're already in a space where they're getting that quicker approach. So it comes down to the people who care about that much performance and have a reason they need reference types in relation to having that much performance. So it really is a tiny set that gets affected by this.
Yeah. That's why I've mentioned that, if we ever do this, I would expect it to be like, kind of some special configuration option somewhere where you can kind of fine tune the thing to be exactly like what you want.
So one of the things we talked about maybe that we would discuss is our ARM64 journey, since it's such a topical topic these days. Could you talk a little bit about that, Jan?
Sure. We cannot talk about ARM64 before talking about ARM32 first, because that was actually significant, that provided significant foundation for ARM64. The ARM32 journey actually, it was started by Mono Runtime when they needed to target devices. That was actually before we had even thought about having ARM32 for the Microsoft version of .NET at the time. When I first started to work on ARM32, it was we actually, the first device we brought it on, it were these like little Beagle boards. I think you can still buy them. It was basically a board that was this big. It was super slow. It was connected through serial cable, so it was interesting developer experience. But that was the first device that ARM32.NET ran on. Then we have we first made it functional. Then we did a few rounds of performance tuning that were motivated by running on Windows Phone at the time. It was a good project. I have good memories of that project, even though Windows Phone as a product didn't survive for long, but there was a lot of energy, positive energy in that project. And then ARM64 became a thing. We followed similar journey with ARM64. I don't actually remember what was the device we did ARM64 first on. Maybe it was Raspberry Pi. I don't know. Actually, it couldn't have been Raspberry Pi. Raspberry Pi wasn't 64-bit. I think it may have been the Tegra ARM64 boards. And we first made it functional, and for in .NET 5, I think it was in .NET 3.1, it became kind of functional. In .NET 5, we have done some amount of performance tuning on it. But it's we kind of, from the measurements we have done, we still know that it's not great, but it's something we hope to double down on in .NET 7. For example, so we are already starting on, even though we haven't shipped .NET 6, the team is already starting to work on .NET 7. So we are starting to measure and analyze. And for example, we realized an interesting number we collected is that one of the Tech Empower benchmarks was 4 times slower on ARM64 than on compared on similar Intel hardware. And we realized that the code that we analyzed that problem and found that the code that computes the cache sizes on ARM64 wasn't working properly. So the GC tuning was way off, and it resulted in 4 times worse performance. So that's something we have pending a fix for somewhere. And I expect in something .NET 7 we will have much more of these, and we will be tracking the ARM64 performance more closely to get it on par with the other platforms.
Could you talk a little bit about our M1 journey, since a lot of people are going to be personally experiencing our ARM64 work on that device?
Yeah, that was the M1 raised importance of ARM64 as a target. So originally we thought about it as ARM64 runs on devices that's covered by Mono. ARM64 runs on servers that's covered that's covered by Core CLR, and the client kind of was there, but it wasn't anything super major. But the M1 journey and Surface X, that's also ARM64 device. Both those kind of raised the priority of it. Yeah, the particular challenge with the M1 is that it has emulation for x64. So when you install .NET, you can end up with 2 runtimes, one ARM64 and one x64 on the same M1 machine. So we had quite a bit of work to do to figure out how to kind of make both those runtimes coexist, because by default they would install into same location. That obviously didn't work well when you installed x64 runtime and installed in a location, and when you install ARM64 runtime and it overrode the x64 one. That wasn't good. So thank you, Rich, for driving the design for this. I think we landed in very good spot.
I'm happy.
Yeah. Basically our approach there is to prefer the native architecture as much as possible. Because over time we expect that people will just have ARM64 runtime on ARM64 machines, but for the time being, during the transition, the x64 runtime has to be there too. So we found the design was focused on finding good ways how to not compromise this long-term vision, but at the same time, make the experience with the x64 runtime smooth.
So let's speculate for a moment, since that's always a safe thing to do. So the rumor is that Apple's going to be shipping their M1X device next week. You know, as far as I know, we have no information about that. But would you guess that we have something to do to react to that from a .NET team perspective, or probably not?
I didn't expect we would get some major fire from it. I expect that over time we might see few bugs that are probably intermittent crashes coming out of that. So one thing that's interesting is that when the hardware gets faster, some bugs that especially race conditions that weren't hit before suddenly start showing up, right? So I can expect we have one or two of those.
Yeah, that'll be fun.
I can share a story, like from a long time ago when we were working on the .NET for SQL Server support. We kind of knew that running in SQL Server, it has to be robust, and we have to stress the runtime a lot. And we had our stress team basically focusing on it, and our stress was all green, and then we gave the bits to SQL team, and it was all red. It was crashing left and right. Like the uptime was like much less than expected, and we kind of looked at, okay, where we have the test hole, like we are stressing it and it's all green on our side, and on your side it's all red. And the difference was that the SQL team had these like top of the line 16-core machines at the time, and our stress was running on this like low end 2-proc machines, and that was the test hole. So.
Totally believe it. So you wrote a doc, maybe Emo can share it on, let's talk about the security mitigations one. I think that's pretty interesting. Yeah, not that one. Not that one either. I gave you the link for it. So you wrote this doc on security mitigations. Could you talk a little bit like why security is so important, and kind of what's the plan look like that you put together?
Yeah, so the security as a broad theme is very important for .NET and for Microsoft in general. It has many aspects. We have to just to give you some examples. All engineers on the team have to go through security training at least once a year. We are shipping, the monthly security updates. We are, trying to participate. We are participating in the, global security community by, in the CVE system and such. So the security mitigations are just one tiny slice of it, but from the runtime point of view, it's important one. And what is it about is that there's this concept in security that's called defense in depth, and it's about basically having multiple layers, so that even if you have like a security problem in one layer, the next layer hopefully can catch it, right? So basically have I think the original meaning of the term was kind of from the word theory or something, that you basically have multiple layers of defense, and the runtime security mitigations are about the defense layer in the low-level runtime. So there are things that the runtime can do, for example, to reduce impact of buffer overruns. If your user code has buffer overrun,
Emo, you're sharing your screen probably more than you want. Sorry, Jan.
Okay. Yeah. So the runtime security mitigations are about the kind of defense layer in the lowest level of the runtime. Great example are buffer overruns, right? So if the user code has buffer overrun, or a library has buffer overrun, it's bad. It's a security bug that we need to go and fix. But because of the security mitigation for buffer overruns into .NET Runtime, maybe that bug isn't actually exploitable. Because of, it's very hard to exploit it because of the runtime layer catches it. And so what has been happening in recent years that both the software or the operating system people and the hardware vendors have been thinking hard about how they can provide more of these defense layers that are these low-level defense layers. And this doc is about basically this doc enumerates all the state-of-the-art defense layers that are applicable to the lowest levels, kind of the hardware, OS, operating system, runtime levels, and what we are going to do about them, and tries to suggest or propose what we are going to do about those in the runtime, in the .NET Runtime, so that it kind of stays, so that it stays as the in state of the art in this area.
Right, secure and competitive in that landscape.
Yeah. Mm-hmm.
If you're going to keep up that doc emo, could you at least show the table of contents so that people can see many of the? Yeah, that's the meat of what Jan was kind of alluding to. So there's several different kind of techniques and mechanisms and threat vectors that we have to take into consideration, and many of them have nothing to do with .NET in particular. They're generic, either generic to programming languages at large, or maybe slightly more specific to one category or another.
Yeah.
Okay, we've got 5 minutes left. So here's a security one. We can probably drop that, go back to full screen emo. Do you want to address this one, Jan?
Would be mitigated back in. I'm not sure about this. This is the first time I'm seeing something like this. It feels like more like a libraries kind of security feature to me. I don't know.
Okay. Yeah, I don't have context on what this would look like.
But I think just guessing about the context, I think it's basically another of these, defense in depth layers that that applies in certain layer of the stack. For example, ASP.NET is also has some of these defense in depth kind of techniques that are in that layer of the stack. So this sounded like one of those, maybe. And
here's an ARM64 question. Well, I guess it kind of starts here.
There is quite a few differences between ARM64 and x64. We try to, where possible, we try to make the differences kind of not leak into the programming model, but it's not possible, or it's prohibitively expensive in some cases, and the memory barriers or missing memory barriers, the kind of the memory model and memory consistency guarantees are different. I agree. It can lead to surprises. The surprises from this is something that people tend to worry about a lot, but in practice, I don't think it's when you compare it with general race conditions. that are not ARM64 specific. This isn't, at least from the code we look at, more common than just general trace conditions. Basically, like if you have some log3 code or missing clocks, you will see it on. Most of the time you will see it on non-ARM64 hardware as well.
Could you talk about, like, I know in the distributed computing space, there's this eventual consistency sort of model. Could that be a thing in this space, which is, if we could do, whole program analysis and flow analysis and understand of, like, well, we actually don't need consistency now between, like this variable state doesn't actually need to be projected to all cores at this time because it's not actually going to be used right away. Like I assume right now we don't have that kind of insight, so we have to be more conservative. Is there a world where we could have more insight and we could be less conservative but still correct?
I think it depends on the backward compatibility kind of guarantees we have. Some of this is also related to the green threads or Java Loom discussions that we discussed earlier, right? It's really hard to write this tricky multi-threaded code. So in practice, like most of the code out there is single-threaded. So that's what people can write and reason about. When you have like these multiple threads, modifying state, it works in kind of small clusters, but as a building large applications using that model, it's super hard. So, I think we would kind of try to optimize more towards the simple model, where your code is at least conceptually single-threaded, and have some special provisions for the places where it's not desirable or where people want to kind of optimize it beyond that.
Makes sense. I feel a need to raise this particular one up. Yeah, we try and read all the comments as they come in and try and push up the ones that are going to be the most relevant to the largest audience. We should probably respect Jan's time so that he can go design some more features with Jared.
I can stay a little bit longer. That's okay. Fine. That makes, yeah.
So why don't we maybe grab one or two more questions and then maybe call it, since we are at the end of the hour.
Yeah.
So performance. We think a lot about performance, a lot. What about comparison?
We do, like, the most publicly known comparison is the .NET Thinking Power benchmark. Right, that's actually run by third party, so that gives it more credibility. For kind of micro benchmarks, it's actually sometimes we do these comparisons. There are multiple things to worry about or that are challenging. One is that when you have, say, micro benchmark written in C and you just convert it to C# in kind of one-to-one way, it doesn't look like natural C# code, and it often doesn't perform well either. So how to do these kind of comparisons, it's hard when you are creating the micro benchmark yourself. So we kind of like, I think I like these micro benchmarks that are kind of run by third parties better, because of those systems usually allow each experts in each domain to submit the best and the most natural implementation for each platform. Another example is the the benchmark games, I think it's called, or yeah. So we look at those. One more thing about comparing about some of the other environments, that some of the other environments, Java in particular, come with restrictions about benchmarking. So we are we do read the license terms, and when the license terms don't allow us to benchmark it, we just don't do it. So that's something to keep in mind too.
Right. So with this next question, I imagine Emo and Jan might have different answers. So can you answer this from your more runtime oriented perspective? And it doesn't even have to be an API. It could just be a runtime design choice.
I think the biggest regrets, I think it's some of the decisions that were made in early in .NET Framework 1.0 days that were basically borrowing some of the designs from Java that kind of didn't work. That I think could have been done in a better way. Example are the covariant arrays, that when you have array of object, it can be actually array of string that's causing all sorts of corner case problems, and we have to pay extra cycles for it in many places. And another example from the same bucket is the implicit lock that you attach to each object, basically the monitor API, that you can do monitor enter on object. That's also kind of, I think, less than ideal design. But these choices were made very, very, very long time ago.
Makes sense. Here's a quick question on SIMD. So we actually have had this question, not this exact question, but it comes down to like which numeric types does SIMD support? Could you speak to that? Or is this a Tanner thing?
That's kind of that. Yeah, that's kind of Tanner thing. I know. We have some API proposals that have been sitting there for a long time about adding double precision versions of some of the the numerics types. It's it's there somewhere, and it's not there in other places. Yeah.
Okay, well, it looks like we got it from the source.
Yeah, Tanner's the source on this one. So yeah.
Okay, well,
not yet, not yes, but yeah, we love our typos.
Yes. Okay, well, I think we should probably, yeah, he says, yeah, so I think we should probably call it at this point. We're a little bit over.
We are, and everybody's got things to do today, and I'm so happy everybody joined us. We had some great questions, and Jan, that was great fun getting a chance to respond as we went along to what was on people's minds. So it was great.
Yeah, it was a pleasure to chat. Thank you.
Thank you, Jan. Always fun. I think we've got a JIT team meeting to go to now on .NET 7 planning.
Mm-hmm. Yep. Okay. So thank you.
Okay.
Bye-bye.
Thank
everyone.
you.